Hi friends, I guess we are live and today I'm going to focus mostly on the screen sharing itself, right? So I hope everybody can hear me. Just please confirm that if you can hear me. Uh, so I'm also testing it from my end. Again, I can hear myself fairly clearly, no issues whatsoever, and things are looking good. So I'll stay on this page right now. Again, we have the whole question paper, everything here. So we'll go question by question. I also have a timer set up here. So hopefully everything should work, right? I'll wait for a few more minutes because I'm almost 5 minutes early. I thought I'll answer a few questions on the live chat and wait for others to join in. We'll start the session sharp at 7:03 p.m. Indian time. Okay. So I have all the questions set up here, right? In the meantime, again, I'm just sharing my screen here. I hope everybody can see me. And yeah, all is well. I'm audible. Good. That's good. Hey folks, thanks for joining in. Let's wait. I'm a little early, so if you have questions, please shoot them on the live chat. I'll try to answer a few questions. I'll keep the screen as is because I want to focus more on the problem solving in this time around. Hey folks, thanks for joining in. Thank you very much. Hey. So again, as we mentioned earlier, this is the first time we are doing this experiment, so please excuse any glitches that we may have, because this is the first time I'm doing this live interactive problem solving session. We have done this for our AI course, more like a one-to-many interview thing, but we have never done it for Gate itself, so please excuse any small mess ups that we might run into. So somebody is asking some difficult previous year questions. We can certainly do this, right? So again, for batch 1, once all your subjects are over, we'll start creating subject tests, multi-subject tests. You'll keep writing tests till Feb 1st. Don't worry about it. We'll ensure that you get ample amount of practice till Feb 1st. Okay. So any batch that is with us, we are not going to leave you. We are going to get you to take as many tests as possible till the 1st of February 2020, right? So somebody is asking about some previous year questions. So we can certainly do that. Again, the last time around when we did some non-interactive live sessions with only questions, we would take a question, we would answer, question, answer, question, answer. The response was not that good, and hence we discontinued that type of experiment. This time we hope, as we are coming closer to the exam, we hope that more interactive problem solving, trying to simulate what actually happens in a classroom, right? Again, the whole idea of this came from both students, and we also got inspired from offline classes where we said there is a lot of competition, right? So we thought we'll try to mimic some of the advantages of an offline classroom through a live problem solving session. So here I'll show you a question. I'll start the timer. If it's a 1-mark question, I tell you how many minutes you have to solve. Please solve the question, put the answer here, right? Tushar, you say that you're not getting time to solve practice questions, but you're doing videos. That's almost useless, to be honest with you. If you do not practice questions, it is useless for you, right? So somebody is asking about P, NP, NP hard. We've covered all of that in theory of computation. We are now doing compiler design. Hopefully we should finish compiler design by 21st, worst case 22nd, right? Again, what is the ideal time to complete syllabus? There is no ideal time. The earlier you finish, the better it is, as always, because you get more time. And I would recommend that you finish at least by November, so that at least by November end, worst case, try to finish everything by November end, so that you have a couple of months for revision and practice, right? So the earlier the better, as always. Okay. So we have already covered computational classes, as I mentioned earlier, right? So if there is anything missing, do let us know. We'll add those sessions. So all of that is already there in our course. Okay, I think many of you are here. I'm also looking at the chat window. Any questions, please shoot them. I'll try to answer. And let's wait for everyone, because we asked people to join at 7 p.m. I've joined slightly early, just to ensure that everything is good, everything is working out, right? So this is going to be a good interactive session, I hope. Okay, so let's wait for a while. Again, folks, please understand that if you go through theory, if you do not solve problems, unless you are a brilliant problem solver by nature, you will not be able to crack gate, right? So 60% in practice tests is okay right now. If you're taking some of the practice tests, if you're getting 60% marks now, that's not bad, because you still have about 5 to 6 months to get that 60% to 75, 80%, which is where you have your comfort zone. Again, somebody is asking about computational classes in GATE syllabus. It is not exactly called out. If you look at theory of computation syllabus, they stop at undecidability. But we have seen previous year questions, not in the last 5 years, but prior to that, we have seen questions from NP completeness, right? So we thought we'll cover some basics of NP completeness, NP hardness, NPP, etc. So that's why we finished that content also. So after compiler design, we are thinking of starting operating systems, because that's a big chunk subject. Then the plan right now is operating systems, computer networks, and computer organization. I'll be teaching all the 3 subjects. We are hoping we should finish by 21st, 22nd, we should finish compiler design, and then hopefully by late September, early October, again we'll move things faster enough, and hopefully we should get things done by late September, early October, worst case mid-October. We want to have everything in there so that people can do things, right? So somebody is asking for NFA, if initial state is final state, will it accept every string in sigma? No, if the initial state is final state and if you don't have any other transitions, it only accepts epsilon. It can't accept every string in sigma star, right? So how to trust oneself? See, look at this. At the end of the day, as you come closer to the exam, start solving more and more problems. Your confidence level, your self-trust, your self-worth, everything will improve as you start solving more problems. Just watching videos or reading textbooks is not sufficient. Okay, folks, I think we are almost there. So let's get started with the live session itself. Let's get going. So this is the first interactive session that we are ever doing. The model is as follows. I'll show you a question. I'll start a timer. If it's a 1-mark question, you get 1.5 minutes to solve it, right? If it's a 2-mark question, we are going to give you 2.5 minutes. Some of you may say that's too little a time, but let's always prepare. Let's always prepare to some, because in the GATE exam, right, you have 100 marks, you have 180 minutes, right? So which means you have 180 minutes, which means for every mark you get 1.8 minutes, right? Which means for a 1-mark question you get 1.8 minutes. For a 2-mark question you get 3.6 minutes. But we want you to prepare for something harder than GATE itself, so that GATE exam will feel like a joke. Okay, even if you get a hard GATE question, you should be able to solve it within this duration. So I'll start a timer. I'll show you a question, 1.5 minutes. Anyone who gets a solution, feel free to put it in the chat window. I'll keep looking at the chat window itself, right? So please don't worry about it. Keep looking. I'll show you the question. I'll keep looking at the chat window itself, right? So whoever answers first, I'll call out their name as soon as the timer runs out, right? So looking forward to this. So let's get going. Again, folks, this is the first time we are doing this interactive problem solving session. So please excuse any glitches. I will also learn. This is the first time we are doing it. I've never done this. If there are any glitches, any feedback, please do send it. We'll constantly improve ourselves, right? So the topics are finite automata, regular languages, regular grammars. Okay, let's get started. Okay, the first question, folks. Okay, let me also have the timer here. Okay, let me also have the timer. The first question. Okay, let's get going. This is the first question. It's a 1-mark question and I'm starting the timer now. You get 1.5 minutes. If you get an answer, please try to put it in the chat window. The timer started already, 10 seconds up. 1-mark question, you get 90 seconds or 1.5 minutes. Easy question. Easy question, folks. Easy question. That's the best strategy. Okay, some people have been putting up the answers. Please be very sure before you put in the answer. You still have time. 1 minute up, you have 30 seconds, folks. Please be very sure before you put in the answer. There is no hurry. You get 90 seconds to answer this question. Okay, you have 15 more seconds. Easy, easy. Okay, stop. Okay, you're done. 1.5 minutes for a 1 mark question. So I was also looking at all the answers. I think Sahil is the first guy who got the answer correctly. I'm just looking at this. Maybe again, some people have answered 1, 2, 4. No, 3 is the right answer here, right? I'll show you the solution also. I'll explain you the solution. I think Sahil Arora is the first guy or the first person who came up with the answer. Then you have estimating the life. Then you get a bunch of people who have started answering correctly. So on and so forth. Again, guys, you have time. Don't be in a hurry. So let me quickly explain the solution. I've written down this solution. I'll share this whole sheet with you also. The reason we have written down the solution is so that we can walk through the answer very quickly. Okay, what does the question say? Let's look at the question first, right? It says minimum number of states in the deterministic finite automata that accepts the given language, where W is any string not in A star B star, not in. So which means first we construct a deterministic finite automata for A star B star, and then we swap final states to non-final states. We have discussed this in the course videos also. Again, this is a very simple thing, right? So if L is the set of words where W is any string not in this, let's construct this complement of this. Let's construct the complement language. Let's construct, which means L dash now is a set of words where W is any string in A star B star. For A star B star, I can construct a deterministic finite automata like this. Look at this. This is my A star. Look at this. This is what I'm getting as my A star, right? This is my final state. Then 1B or more B's, right? 1B, 0 B's or more B's. I'll keep staying here, right? A star, B star. So these two are my final states. And again, we have to have a deterministic finite automata, which means all transitions should be defined here, right? So this is, again, the language accepted by this finite automata is L dash, which is equal to sigma star minus L. Now, how do I construct the complement of this? Complement of complement is the language itself, right? So how do I construct for this? I simply swap the final states with non-final states. So the non-final states become final states. Sorry, the non-final state becomes final state. The final states become non-final states. This is the minimum number of states. The answer here is 3. Very simple question, right? Again, those of you who got 1, 4, 2, please think about this. Again, since we want to solve as many problems as possible, I will not be spending too much time. We'll share this document with you. Those who have done a mistake after this live session, please go and think, check your notebook and ask yourself, why did I get a wrong answer? What was I lacking? What topic or what concept was I missing? Go back and learn that concept. In here, because what we want is not in A star, B star, the concept here is it's easier to construct the deterministic finite automata for L complement, construct it, and then change final states to non-final, non-final to final. That's it. Very simple example. You can easily solve this in 1.5 minutes, right? Very simple. So again, good job, folks. Good job. Some of you are doing good job here. So let's get going. So let's start with the next question, right? Let's start with the next question. Okay. Fingers. Okay. I'm just putting it out. Okay. Here is the question, folks. Again, a 1.5 minute question. Right? A 1.5 minute question. I'm starting the timer now. Fairly simple question. Question 2. Okay. I'm looking for answers now. Again, since our intent right now is to solve questions, I'm not going too deep into the answers. We'll share this whole sheet. You can verify and understand where we have gone wrong. Okay. Or some of you want me to zoom this. Okay. I'll zoom this a little. Okay. Okay. I'm already on full screen mode. Okay. 37 seconds up. Guys, please take time. There is no hurry. You have 90 seconds. It's only 50 seconds up. You're only halfway through. There is a lot of time. Think through. Okay. We have 10 more seconds. Think about it. Three, two, one, zero. Time's up, guys. Time's up. Time's up. Okay. Some of you have written answer A. I think you fell for the trap here. The right answer here is D. Okay. Only 1 is true and 3 is true. These two are true. 2 and 4 are not true. Okay. Again, I think Sashi Jha got the correct answer. The earliest correct answer is from Sashi Jha. Okay. Very good job. Again, some of you got confused between A and D. Okay. So some of you have even said C, but mostly between A and D. Good job, guys. Good job. Good job. So let me explain the solution here. It's actually very simple. Look at this. Can I generate BAA using this? A star, which means this can be epsilon. This can be 1B. This can generate 1B. This can generate 2 A's. And if this is epsilon and this is epsilon, BAA belongs to this. So this is true. Okay. Now if 1 is true, look at this. If 1 is true, let's start eliminating it. Instead of checking all the 4, let's start eliminating because we have to do it fast. Which means this option is correct or this option is correct. These two cannot be correct because this has 1 and 2, this has 1 and 3. Okay. Now if you notice this, okay, this is the simpler one to evaluate because here you have, look at this, you have this here, you have this here, right? You have both of them. Is the intersection between both of them epsilon null set? Is the intersection between both of them null set? Right? So is that the right option? Let's see. Is this the right option now? Okay, let's see. Is the intersection between both right option? Okay. Sorry. I think option A is the right answer. Sorry, not D. Sorry. Option A is the right answer. I'm sorry. Option A is the right answer. Sorry. My bad, folks. My bad. Sorry. My bad. Option A is the right answer. So unfortunately, it's not Sashi Jha. I forgot. It is Diya Basu who got the answer the fastest, right? So option A is the right option. Why is option A the right option? Because look at this. Now I have to choose between A and D. Okay. So now if you notice, this has epsilon, which means epsilon belongs to this intersection, which means this cannot be null set. So this cannot be true, which means this option cannot be true, which means A has to be true. Very simple. You can actually solve this in 30 seconds. My bad, folks. Sorry. The right answer is A, not D. My mistake. I've written a wrong answer in my notebook. My bad. Okay. The correct answer is A because 1 and 2 are correct. Okay. Simple elimination strategy. Okay. Good job. Sorry, my mistake. Again, this is the first time I'm doing it, so I might mess up a few things. Okay. Sounds good. I'm also solving it parallelly with you. Okay. I'm also trying to solve it. Okay. So let's get going, folks. Let's get going. So 1 and 2 are correct. 3 is false. 4 is false. Again, we just simply eliminate. In the examination, instead of evaluating all 4, just keep eliminating the options. That's the fastest way. Next question, let's get started. Again, I want to solve as many problems as we can. Okay. If there are any questions or clarifications you need about the solutions that we give, feel free to reach out to us over email. In this session, I want to solve problems. Okay. So let's go. Okay. So 1 is true, 2 is true. Actually, I think I wrote the wrong answer here. 1 is true, 2 is true. So A is the right answer. Okay. I'm correcting the sheet also. Next question. Let's start the timer now. Okay. This is a 2-mark question. So you get 2.5 minutes. This is a 2-mark question. So you get 2.5 minutes, folks. Slightly lengthier question, but it's easy to solve it in 2.5 minutes. Okay. Okay. People are starting to put in the answers. I get a few A's, B's, then I got a D, then a B, then an A. Okay. Let's keep waiting. Okay. You still have 1.5 minutes. Please be patient. There is no hurry to put in the answer. It's important to get the right answer rather than the fastest answer. You have 1 more minute, folks. Please be patient. There is no hurry. Think through. Okay, 5 more seconds. Let's get going, folks. Okay, time's up, time's up, time's up, time's up, time's up. Okay, so let me explain you with the solution here, right? So there are 4 statements here. Which of the following are true, right? The first one, if C is a set of regular languages and the finite union C, right? Finite union C, right? Finite set union C, which means you have a bunch of regular languages. If you take the union of all the regular languages, is it regular language? Yes. We have looked at the closure properties of regular languages. The union of 2 regular languages is regular. So this is true, right? Very simple. Again, we can also discuss about how to construct the finite automata, but in the interest of time, I'm not doing that. But this is a closure property. Every subset of a regular language is regular. Not necessary, because sigma star is a regular language, right? Sigma star, all the words is a regular language. I can construct a finite automata for this. But every subset of this, which means is every language regular language? No. Every subset of a regular language need not be regular. So this is false. Okay, so you got true, false. So this can't be the answer. Look at this. This can't be the answer because it says 1 and 2. Can I? Okay, I can't get rid of anything else. I can't get rid of other options. So what does this say? This says x, y, x reverse. Okay, because we have y, which is delimiting x and x reverse. This is a regular language. Instead of this, if we just had x, x reverse, for this we required a push down automata, right? So this language will be accepted only by a push down automata. But since I have a delimiter y, right, because I have y between x and xr, this is regular. This is true. If A and B are 2 regular languages, then the set difference between A and B, which means the word belongs to A but does not belong to B, this is also true. Because remember, set difference, look at this, set difference, regular languages are closed under set difference also, right? Look at this, I can construct a finite automata for words that belong to A. I can construct a finite automata for words that do not belong to B, right? Now I'll accept the word only if it belongs to this and doesn't belong to B. So this is also true. Again, this answer you can answer within 30 seconds if you know the closure properties of regular languages, right? If you know the properties, you can solve this in like 30 seconds, right? So 1, 3, 4, 1, 3, 4. So option D. So who got option D the fastest? Option D. So let me look at this. Okay, I've lost track of it now. But let me see. Just give me a second. Option D. Mayank Prakash. He got the answer the fastest. But again, please understand that speed is not important. Accuracy is important. Because we had 2.5 minutes. While Mayank did a great job of arriving at the solution here, the speed, while you should solve it in under 2.5 minutes, but accuracy is important. Some of you have given options A, B, some even C. So please check the answer. We'll give you a detailed answer for this. After this live session, please go and check out the answer and see where you have done mistake. You should also learn to diagnose your problems, right? So please understand that you have to diagnose your problems. Okay, after this live session, please spend at least 1 hour diagnosing which all problems you got incorrectly. Very, very important part of the exercise. Okay, so let's go for the 4th question now. Okay, 1 mark question, 1.5 minutes. Let me start the timer. Folks, if there is any mistake in the answers or the question, do let us know. We'll correct them. Okay. This has 90 seconds. We are halfway through, almost halfway through. Okay, people have started putting in the answers. Okay, C's, A's, B's, D's, everything in here. This is a tricky question. Ten more seconds, folks. 10 more seconds. 3, 2, 1, 0. Time's up, folks. Time's up. Time's up. Let's see. This is a tricky question because it's very easy to fall for this. Intentionally, we gave you a tricky question. Look at this. W is strings that end in A. Look at AA. This language contains AA also. What happens to AA? A, again on transition A, I reach here. This is not accepted by this machine because only Q2 is the final state. So this cannot be the answer. Okay. W starts and ends with A. Okay. Is every string that starts and ends with A. So this is the language L, right? But this also accepts BAs. Look at this. I'm giving you counter examples. If I have BA, this accepts this. BA does not start and end with A. So this is also not correct. What about this? W contains an odd number of A's. Okay, this is a tricky one where many people fall for. Okay, so imagine if I have this. Imagine if I have A, B. Look at this. Imagine if I have A. So what if I have this odd number of A's, right? So what if I have A, B? So A, B. I'm trying to, sorry. So for the third example, for the third case, right? So what if I have A, B? A, B is not taking me to the final state. Okay. So A, B, right? So A, B. So it says W contains an odd number of A's. Okay, so AB is not the final state. But what if I have a string like this? AB, B, A. What if I have a string like A, B, B, A? A, B, B, A. So this has even number of A's. But still this is accepted by my machine. Look at this. A, B, B, A. This is accepted by my machine. Which means this is also not the right option. D is the right option. We have intentionally give you a tricky question. Right? Because you have to come up with these counter examples here. You have to be very careful with these counter examples. I was also trying to solve this problem parallelly with you. And it's very easy to fall for these traps, to be honest with you. Right? So I think the answer is D to the best of my knowledge. Yes, answer is D. Because I've constructed counter examples for everything. Right? So now who got the right answer first? So let me just track back. I'm just going through the answers that you guys have put in. Okay. Sorry. What happened here? Okay. Okay, I think Chirag Udupa, he got the first correct answer. Again, we're just doing this speed thing to create a sense of competition and to mimic the classroom environment, but getting the right answer is important. Chirag, very good job. This was a tricky question. Very good, very good, very good. Okay, sounds good. So, okay, sounds good, folks. Let's go for the, so anything that you think is incorrect, we'll share this whole document with you. Please go through this after this live session. Please send us your feedback. Any corrections, we'll correct them. Okay, sounds good, folks. So let's get going here. Yeah, here I want to solve the problems like a classroom. Okay, so let's get going. So we'll give you detailed solution also here, right? So don't worry about it. Okay, so let's get going. Next question. It's a 2-mark question. Let me start the timer. So you get 2.5 minutes now. Slightly lengthy question, but please be patient. No hurries, get the answer correct. Okay, I'm also solving this parallelly with you. No hurries, take your time, folks. Take your time. Okay, many people have put in the answers. Folks, sometimes I may misread the person who answered it fastest. I'm sorry about that, because I try to do the best job that I can. If I misread somebody's to be a winner and someone else might not like that, I'm sorry about it. Again, we'll improve this over time. We'll have a process around it. 2 minutes up. You have 30 more seconds. Ten more seconds. 4, 3, 2, 1, 0. Stop it, stop it, stop it. Come on. Okay, let's solve this problem, right? So L is a set of strings of zeros and ones of the form W dash, where W dash is formed by replacing all the ones with zeros and vice versa. This is sort of like your word reverse, but instead of having the word reverse itself, I have the word complement now. See, replacing zeros with ones and ones with zeros basically means I have the complement. To actually construct an automata that accepts this, I need to have a push down automata with a stack. So this is not regular. Again, this is very similar to the argument of word reverse. Okay, you need to construct a push down automata for this. So this is obviously not regular. Okay, what about this? X is a string of zeros and ones, Y is a string of zeros and ones. I have a hash. Obviously regular. You can construct finite automata for this. What about this? A power 2n, where n is greater than or equal to 1, which means I have even number of a's, right? But not 0 a's. Okay, you can construct for even number of a's, odd number of a's. You have seen tons of examples in the course videos. Simple, straightforward. What about this? Okay, so 1, 2, 3 are correct. Sorry, 2 and 3 are correct, right? 2 and 3 are correct, which means this can't be the answer, this can't be the answer. Either B or D. Okay, I'll have to evaluate 4. I can't escape this. So L is bunch of strings made of zeros and ones, which has equal number of 0, 1 and 1, 0. Yes, this is also possible, right? I can construct a finite automata for this, wherein whenever I encounter a 0, 1, I go to a specific state. Only when I encounter 1, 0 followed by, or whenever I encounter 0, 1, I'll go to a special state, or whenever I encounter 1, 0, I have to encounter the other string. If I encounter this, I have to encounter this. If I encounter this, I have to encounter this to go to the final state. Again, I'll show you the exact finite automata itself. But logically speaking, I'm trying to solve it in an examination. An examination, I might not want to construct the whole automata itself. I can answer this. So this is also true. So 2, 3, 4 are true. So D is the right answer here, right? Again, if you want to see the exact automata for the fourth option, I have it here in the solution. We have constructed it for you, the detailed one, right? So let's look at who got this right. Okay. I think Anurag Sharma got the answer the fastest. But again, speed is not the only thing we are looking at. I hope many of you got the answer right, D. Some of you have gotten C, probably because you got confused about 2, right? Don't get confused. Actually, this is a fairly simple problem. Even though it's a 2-mark problem, I have to evaluate all the 4 options. I can't run away from evaluating all 4. It's an easy problem. It's not a hard problem, right? So good job, guys. Good job. Very good job. So let's go to the next question. Again, as I told you, if there is any mistake in the question or the answer, or we forgot to handle a boundary case, do let us know. We'll correct it. Okay, sounds good. Again, I'm not going too deep into the answers because I want to solve as many problems as possible. We are 30 minutes in. We have only solved 5 problems. Let's do it fast now. Okay, let's get going. 6th question. Let me start the timer. Where is my timer here? Okay, this is a 2-mark question, so you get 2.5 minutes for it. Question 6. Guys, please don't worry about answering fast. Okay. I know some of you are in a hurry. Please don't answer fast. Try to get the right answer. That's important for me. Just ignore getting. Okay, so probably I want to stop this competition itself because some of you are doing good. But again, speed is like a motivator. But speed is not important. You have 2.5 minutes, so take all of the 2.5 minutes to answer it. Please don't be in a hurry to answer the fastest. What is important is answering correct, not the fastest. Nobody will give you a prize in GATE exam for finishing the exam in 1 hour. Nobody will give you a prize for it. Good. You have a lot of time. Think about it. Think about it. You have 1 more minute, folks. 1 more minute. Good going. No hurries. Take a breath. Take your time. Take a breath. You have 30 seconds. Okay, folks, 5, 4, 3, 2, 1, 0. We're done. This is actually a very simple problem. You can answer this in 30 seconds. Okay. See, look at this. The number of states in a minimal DFA that accept sets of strings when interpreted in reverse as binary string is divisible by 5. For regular binary strings, for division with 5, we have 5 states. Because look at this, we have shown this in the course videos also, right? So if you have mod, so for the mod operator, when you divide a number by 5, right, you get remainder 0, 1, 2, 3, 4. So you need 1 state corresponding to each of these, right? Now whether we interpret the string in reverse or not doesn't really matter. See, this is only to, this option was given, or this concept was introduced, interpreted in reverse, right? Only to fool you. Okay, the answer here is 5. And lot of people got the right answer, thankfully. I think Pankaj Shah was the first person who get it, but please understand, speed is not important. As long as you solve it in under 2.5 minutes, lot of people got the answer correct, right? Again, some of you have gotten it wrong, but most of you have gotten it right. Again, we construct the finite automata for you here. Right? So this is for DFA accepting integer equivalent to binary number. This is for the reverse, right? So we've shown the solution also. Easy problem, 2 marks, you can easily get this, right? Next question, let's go. Okay, so I'll start the timer also. Okay, let's get started. 1 mark, 90 seconds. Some people are concerned about buffering. I'm using a 100 Mbps connection here. Okay, we'll try to find some alternative for this also. Till now there was no buffering, right? So things were going good. Okay, people have started putting in the answers. No hurries, folks. Please don't worry about it. Take your time. Getting the answer correct in 1.5 minutes is important. Okay. Okay, we have 10 seconds left. Okay, so we are done. Sorry. I almost lost track of time. Sorry. We are done. Good. This is actually simple. Look at this. Minimum number of states in a DFA that does not contain 1 as a substring and does not end in 1. See, look at that. That does not contain 1, which means we first construct the finite automata that contains 1 as a substring, and then you invert the final states and non-final states. and does not end in 1, right? So if you start constructing this finite automata, actually the answer here is A, because we want the minimum number of states. I'll show you the finite automata for this, right? So this is actually a simple problem. Again, the way you can answer this question fast is as follows. Look at this. It says does not contain 1 1. First let's construct the finite automata which contains 1 1, right? For the finite automata that contains 1 1, look at this, it has to contain 1 1 first, which means this will become a final state. For the one that does not contain 1 1, these two, the opposite of it, right? So you need 3 states to start with. Again, I have one more additional condition in addition to not having 1 1 as a substring. I have 2 conditions here, right? I have 2 conditions here. Does not contain 1 1 substring and does not end in 1. Just to satisfy this first condition itself, I need 3, literally, right? If you think about it, again, the best way for problems like this is to construct the minimal DFA. And the fastest way to do that is write down the strings that you have, write down the strings that you need to have in your language. And using these examples, you can construct this finite automata. That's the best way. Again, in the course also, we have shown you tons of examples wherein given a problem like this, think of all the strings that should be there in this language and try to construct your finite automata to satisfy this. This is one strategy. The answer is 3. Many of you got it right and some of you got it wrong. So Vikas Thamke, I think he got the fastest. But again, to reiterate my same point, speed is not important. What is important? Again, some of you have written the answer as 3 itself. Very good. Very good. I hope the streaming quality has improved now. I hope. Okay. So let's get going. The next question. We have solved 7 questions, folks. Let's solve. Even though we told you that we'll have 8 questions. I have 10 questions here actually. Let's try to solve all the 10 of them, right? So 8th question. Let's get going. 2.5 minutes. And the timer starts now. 2.5 minutes, 2 marks. Let's do this. Patience, patience. No hurries, folks. You have 2.5 minutes at your disposal. It's just 45 seconds up. It's just 1 minute up. Patience. Whatever solution you got, double check, triple check, because you have time at your disposal and this is an easier problem. You have 1 more minute, approximately. 'Good job, folks. Very good job. I see a lot of you submitting the answers. You still have 30 more seconds. Sometimes you get 2-mark questions that are easy. Okay, 15 more seconds, folks. 15 seconds more. Five, 4, 3, 2, 1, 0. Okay, done. This is actually very simple. Lot of you got the right answer. Mayank, I think, is the fastest here. But again, speed is not the only important thing. Everybody who has got your answer as 3 is a winner here, right? The fastest doesn't really matter. 3 is the answer. And that's very simple. What does this say? Number of A's plus 2 times number of B's mod 3 is less than 2. The moment you see mod 3, this should hint at the fact that the solution will contain 3 states. Because when you have mod 3 or division by 3, you could have remainder of 0, 1 or 2. But again, you have to be very careful. Just because you have mod 3 doesn't necessarily mean you're guaranteed to have 3 states. So, but this hints at 3, right? So then start constructing a finite automata. Because it's a 2-mark question, you don't want to mess it up. You want to get the whole 2 marks, and most likely the answer seems to be 3, right? Because you have mod 3 here. Then your next step that you should ideally do is look at all the strings that should belong to this language. It should epsilon, A, AB, triple A, AABB, etc. and construct the finite automata for this, right? Very simple. This has 3 states. It's also very easy to construct this finite automata. By just looking at the question itself, we got a hint that it must be 3, but we are not sure. So let's draw the finite automata. Since it's a 2-mark question, you don't want to mess it up. You want to get the whole 2 marks, right? Easy question, easy busy question, very easy to crack. Okay, good job, folks. Many of you got 3. Some of you got 9. I think. Okay, that's okay. That's okay. It's okay. It's okay. Sometimes hota hai. Okay, sounds good. So let's go to the next question now. Let's go to the next question now. Okay, this is also a 2-mark question. Let me start the timer now. Let me start the timer now. It's a 2-mark question. You have 2.5 minutes. This is a slightly tricky one. It's not a hard one. It's a tricky one. Oh, people have started answering the question already. Okay. Which of the following are regular, right? Okay, so let me also solve this. Okay. Okay, one more, roughly about a minute more. Okay, it's a 2-mark question. Think through carefully. Very easy to fall in the trap. Okay, time's up, folks. Time's up. Time's up. Time's up. This is a tricky question and very likely to do a mistake. As I told you, this is a slightly tricky question. Okay, I see lot of wrong answers here. I hope my answer is not wrong. In case you find that my answer is, or our answer is incorrect, this is not my answer. It's the whole team who puts in the effort, right? If you think our answer is incorrect, do let us know. Okay. So let's go through this question. Okay. So only L1 is regular. Only this is regular. This is actually a context-free language, right? So only L1 is the right answer, and I see lot of C's and D's. Okay, this is a tricky one. I think Tuhin Datta, I think he's the first person who got the right answer. Again, speed is not important. Many of you got the wrong answer, but that's okay. That's okay. We all learn from this. Oh, thankfully, as people spent more time on this problem, they got the right answers. Very good. So people who spent more time, people who were in a hurry to answer, many of them got wrong because they either said C or D. But people who spent the time, who answered the last, but within the time, but who answered the last, actually got more right answers. So patience pays. Okay. So let's look at the answer itself. It's actually a little tricky. Okay. So what is our language now? Look at this. Our language L1 is a power p b power q, where p plus q is greater than 10 power 6. What is the complement of this language? What is the complement of this language? Complement of this language equals to this. The number of, see, I should have a bunch of a's followed by a bunch of b's. Okay. But the number of a's and b's should be less than 10 power 6. Okay. Which means I can have a finite number. Look at this. This is a finite number of, there are a finite number of words that belong to L1 dash, which means I can construct a finite automata. Right? I can construct finite number of states to count the number of a's and b's, because 10 power 6 is a finite number. Right? Which means L1 dash is regular. And we already know the closure property, that if L1 dash is regular, the complement of L1 dash, which is L1, is also regular. So we are using both the properties of closure. See, this problem is slightly tricky, because look at this. We are applying the closure property of complementation of regular languages along with this simple idea that the number of words that belong to this L1 dash are finite. Right? Hence, I can construct a finite automata with finite number of states. So L1 is context free because of these two principles, right? Now next one is this L2. What about L2 now? L2 consists of a power m, b power n. Okay, L2 consists of a power n, a power m, b power n. Actually, we can answer this without using the complement principle also. We can solve this without using the complement also. Okay, what do I want? Whenever I see a string of a's and b's where the number of a's and b's are greater than 10 power 6, after that, if I see any, look at this, after that, so whenever I do that, again, this is one solution to this. Let's look at this, right? As far as L2 is concerned, I want to just go a little fast here. Okay, so as far as L2 is concerned, look at this. I have a's and b's, but the difference between a's and b's equal to this. We have actually shown an example of this in the course videos also, that to solve a problem like this, I need to start pushing a's into stack and keep popping when I need b. So we have actually shown this. Okay, whenever you have m and n, whenever the difference between m and n is greater than or equal to some variable, some number here, this requires a stack. The moment you require a stack, this becomes a context-free language, right? So very simple example here. Again, if there is any error, please do let us know. We'll correct ourselves. Okay, it's very easy to do silly mistakes. Probably we might also have done some silly mistakes here. So if you have done a silly mistake, do let us know. We'll correct ourselves. Okay, please do just send us an email. We'll also look at the whole chat window a little later and respond as fast as we can, right? So last question, folks, last question. Let's do this. Okay, 1.5 minutes. Let's do this. Guys, I think the answer for the 9th question is incorrect. We will correct that. I'm sorry for that. So the answer for the 9th question I think is incorrect. My bad. Okay. I think in the notes that we got, yeah, I think the problem there, I'm just looking at some of the comments that people have written. I think L1 complement, Mahesh called this out for the previous question. I think L1 complement is wrong. I'm sorry. So we'll correct the answer for that. My bad. Okay. Sorry for that. Okay. So let's look at this. Mine, good job. Thanks for calling it out. We'll correct that answer. Our bad. We'll edit this document and upload it for you. So 30 more seconds. Let's get going. I think the answer is correct, but the logic of complement is incorrect. If I think about it, I think the explanation is incorrect. So I think the answer is correct. Okay, because when I was solving it, I was thinking from the perspective of actually constructing. I think the 9th one, the answer is correct, but the explanation is wrong. Okay, okay, time's up, folks, time's up. Okay, before we answer this, let me just call out. I think this explanation is incorrect, right? This explanation is incorrect. We cannot, because the complement of L1 is not L1 dash. So there is an error in this notes. So we cannot use this logic here, but this is regular because we can construct a finite automata for this. Sorry, I think the complement logic is incorrect. Thanks, Mayank, for calling it out. Our bad. I think we got the answer. The answer is correct. The answer is correct. Just the argument that I gave is incorrect. I'm sorry for that. Okay. We'll correct. I've already corrected here in the document itself. Okay, so 10th question. Okay, let's go for this. Okay, let's solve this first and then we'll see who won. Or see, everybody who answers correctly has won. Okay, set of regular expressions. What is the language generated by R? Set of all strings that do not contain AA. Okay, so B is also a string that does not contain AA. Is B generated by this regular expression? No. So this cannot be the answer. First option gone. Second option. Set of all the strings that do not contain two or more consecutive A's. Two or more consecutive A's. Oh, for example, imagine if I have a string like this, just string B. Let's assume I just have string B or BB. This does not have two or more consecutive, oh sorry, that do not contain, so set of all strings that do not contain two or more consecutive A's. Yeah, this string does not contain two consecutive A's. This string also does not contain two consecutive A's. But these strings cannot be generated. These strings cannot be generated by this because you have B, B star, A. So if you place this B, you have to place this A. You can't run away from that. So this also cannot be the option C. We also have none of the above. So we have to rule out all these three. Set of all the strings that do not end with B seems logical because look at this. The string has to end with A. The string has to end with A because of this, or if this is epsilon, the string has to end with A, or the string has to end with epsilon. Okay. So strings that do not end in B, this makes sense, and do not contain two or more consecutive A's. Look at this. If I have A here, this has to be concatenated with a B. And if I have B's here, after this A, I'll get a B, which means I can't have two A's. So this also makes sense. So C is the right option here. Right? Fairly simple. This is actually a simple problem. Let's see who all got the right answer. Okay, I'm going above. Emperor Big A. I don't know who this person is, but he got the right answer. Okay. So, okay. But a lot of people got right answers here. And sorry for the mess up with 9th question. We'll be more careful from next time to give you more. The answer is correct, but the explanation should have been better. We did a mistake there. Okay. So anything else that you find a mistake, do let us know. We'll constantly improve. This is the first time we are doing this. If we messed up anywhere, sorry for that. Most importantly, okay, so this is done. There are a couple of announcements that I wanted to make before we part our ways. Number one is the fast track batch 11 is starting from 23rd August 2019, right? So I see very, very interesting participation in this. I mean, this is much, much better than what we expected. I see hundreds of students actually parallelly solving these questions. Very interesting. Thank you for your participation. If your participation, and please give us feedback on constructively how to improve ourselves, because this is the first time we are doing it. And anybody who is interested to participate in more of these interactive problem solving sessions and to attend more of our live sessions and to be notified about it, please follow and subscribe our channel so that you get these notifications and you don't miss out on anything, right? Again, this is the first time. If we messed up, apologies for that. And we strongly believe that this would benefit students, and please give your feedback. Always feel free to send us an email. Go to our website. Let us know what you have, what you think about this. If this is beneficial to any student, whether they are a registered student or not, doesn't really matter, right? As long as it benefits all students who are taking it, we want to help them in whichever way we can. If these live sessions are good, let's start doing them, right? So we finished it in under an hour. Very good job, folks. Thank you very much for joining in, and thanks a lot, folks. Thanks a lot. See you again, and please give us your feedback so that we can constantly improve ourselves. Okay. Thank you, folks. Thank you very much.